everyone. Welcome to DevTool Time. Really happy to see y'all. I was on vacation, but I'm back. And in case you are new, DevTool Time is a web series where we invite awesome developers to showcase their remote work setup, their favorite dev tools. They share with us their favorite productivity hacks and more. So today we have someone really special with us, very known in the SRE world, Liz Fong-Jones. And let's start off with just some introductions first. So I'm an SRT. I'm the community advocate at SourceGraph, and Byong, you're next.
Hey everyone, I'm Byong. I'm the CTO, co-founder here at SourceGraph, and I'm super excited to welcome Liz to the show. She has got such a cool developer setup, and she's been, principal developer advocate for Honeycomb for many years, and she's going to show us some, I think, like neat tricks also, right, at the intersection of dev and ops and perhaps in Honeycomb itself.
Yay! I'm really excited for this. Hi, I'm Liz Fong-Jones, and as mentioned, I'm now one of the two principal developer advocates at Honeycomb. I've been at Honeycomb for 2.5 years now, and previous to that, I worked for 11 years at Google as a site reliability engineer.
Nice. Cool. Should we start off with one of your remote work setups, which is really interesting? I'm going to share the screen.
Yeah, so let's start with, where I'm talking to you from now, which is I am sitting at my desk in my apartment. And it is not necessarily the most organized desk in the world. I am very much a cluttered person, but this is kind of where I spend a majority of my work time. You'll notice the plethora of plushies and like the custom mug and, mental health represent. Yep. That is kind of where I spend some of my days. But one of the things that we also wanted to touch upon is that, mental health is important, disability visibility is important, and I have a chronic fatigue condition, which means that I don't necessarily have the ability to sit at a desk for, 7 to 8 hours at a time. So one of the places that you'll find me, especially on Monday mornings or especially in the afternoon on any other day of the week, is that if I run out of stamina, you will find me working from bed. In a past life, when I was less senior, I might not have, been as open about it. But, my teammates sometimes will see, yep, Liz has her head on the pillow, like, she's working from bed, right? Like, I don't mute my Zoom camera anymore when I'm working from bed. It's just like, who I am, what I do sometimes. And you'll notice that I pay a lot of attention to ergonomics in both of these situations. Because if I'm sitting at my desk, yes, I've got the, nice clicky mechanical keyboard. I've got, the fancy podcasting setup with the microphones and the headphone and stuff. But it's also important for me to think about, like, how do I make this sustainable? How do I make this something that I can take care of, when I'm in bed? Because a lot of us, have laptops that are really heavy, and that doesn't really work so well. So what I use is actually a Google Pixelbook, 2017 Google Pixelbook. It's really light. I think it's less than 3 pounds. Like it's an ultra light. And therefore I can support it with my pinky finger, and I can touch type with my other 4 fingers and my thumb and on my left hand. And that makes it really, really ergonomical. So I can be perfectly productive while I'm lying down, and it's not really a big pain in the rear end to deal with.
Wow, that's amazing, because I think I've heard of the iPhone supporting Pinky before, but the entire laptop supporting Pinky, that is it's
not really supporting the whole laptop, right? Like it lies on the body of the laptop is on your chest, right? So it's just balancing it in the right position with your Pinky.
Got it.
I do feel it does require a certain amount of skill, because just keeping the balance and the exact perfect angle. I'm sure. Wow.
Yeah, it comes with practice. And I see a Twitch comment asking, do we connect to remote machines or run locally? And the answer is both. And we'll actually get into that a little bit.
Where do we want to start? I know that there's a bunch of stuff in Honeycomb that'd be cool to show off. There's also your terminal setup, Terraform, CI/CD.
Why don't I talk about kind of 2 of the projects that I work on? One of them is a hobby open source project, and the other one is my day job. This is the hobby project that I work on. It is called Roster, and it is a tool for managing my EVE Online corporation. So basically, I've got a list of my EVE characters, and I can pay out ship replacement to everyone in my corp.
And EVE Online is I think it's like a massively online multiplayer game, right? Where you kind of there's like
Yep.
you control clans, and there's like fighting and economics involved, resource management, like all
Yep, including espionage, right? So therefore, we
Cool.
have to have a system for doing our HR. So this is one of our HR systems. So yeah, the interesting thing about this.
Hold on. You have an entire HR system.
Yes, this is our HR system.
Whoa.
Right. So like when I was saying, we pay out ship replacement, right? Like this is essentially like paying people salaries, right? Like we make sure that we are paying people salaries, right? That we're replacing them for the materials that they use on the job.
That's incredible.
We keep a list of all of our members, right? Like, and this is a Vue 3 application using the Vue framework. So yeah, basically it is, my standard workflow here is actually copied from a lot of the things I learned from Honeycomb, right? Things like, we use Circle CI. We've got a bunch of workflows queued up that take care of running our tests automatically. And then we automatically deploy every time that there's something that lands at the main branch. There's no such thing as, as committing something and leaving it to rot in a branch. Everything goes out within less than 15 minutes from the time that I write the code.
Wow.
Nice.
Yes, one of the interesting things, though, is if I... let me just make sure, where am I? Okay. Oh, cool. This is one of the fun branches I was looking at. So obviously, get workflow, pretty standard.
Yep.
So here's actually one of the interesting things. You'll notice that it's like not asking me for a passphrase. Instead, this is controlled by my Yubikey.
Nice.
So I have my SSH key stored in my Yubikey. So even if you were to compromise my machine, like unless you got me to physically tap that button, like, you're not getting anywhere, which is kind of fun. Okay.
For those who don't know what a Yubikey is, can you explain like what it is? It's like this little like
It is
dongle.
a physical token, so it stores cryptographic secrets, and it will only like perform the signing operations or whatever. The key never leaves the device, and it can be configured like I have configured it to require physically tapping the button on the device. So the computer can instruct it to sign whatever you like, but unless I actually tap the button to approve, nothing is going to happen.
So Liz, why is this better than just keeping my SSH keys on my hard drive?
Yeah, so the reason that it's better than keeping on your hard drive is if you are SSHing somewhere and you store your SSH passphrase in memory or something, then anyone who gains access to your computer, to your SSH agent, is going to be able to hijack your SSH keys and get anywhere. So there are two alternatives actually that we use at Honeycomb. One alternative is you can use like a numerical code from your phone to act as your second factor. But the other way is that if we know that you have a physical hardware key, we can configure you to be allowed to just get in directly as long as it is using that secure key that we know that it requires something other than just logging to your computer.
Got it. And it seems like easier too, because like one of the minor like annoyances that happens throughout my day is just like, two-factor auth. I got to pull out my phone and like, okay, copy these 6 digits over. Here you just like press that button.
Yeah, exactly. I just press the button. It's so much easier.
Cool.
So anyways, let me try to resolve this merge conflict, and you'll see a little bit of my workflow.
Cool.
So, right, so now we've got some merge conflicts. So you'll notice I'm editing this with Nano. So this is GNU Nano. And the reason that I use Nano is that it is installed literally everywhere. It is super lightweight, and it is actually, comparatively easy to understand what it's doing in like a editor like VI or in like an editor like Emacs. And it's one of these things where my Chromebook probably would not be capable of running VS Code at full speed, but it's perfectly capable of running Nano locally, and it also can access it. I can SSH to this machine here if I want to do stuff over there as well. So it's kind of remote friendly, and it does basically everything that I need. One of the other interesting things is, let's see. So let's resolve this merge conflict. Right, so after I do this, what's going to happen is it's going to it's going to propose a bunch of changes, and those changes may not be like perfectly correct. So one of the things I have in my package JSON is a workflow that will just automatically run prettier to format it, right? So I don't need formatting in Nano. Instead, I just rely on always, before I like commit a change or before I like submit something for testing, right? Like I'll always run prettier in order to format it up. Or if I'm working in Go, I'll use Go format, right? So those are kind of some of the ways that I work around it, right? Like it's very Unixy. It's kind of the separation of concerns, right? Like editing is editing to me. And let's see. Let's look at one of these files, right? Like, so if I edit one of these TypeScript files, you know, it looks perfectly fine. Actually, I should turn on JavaScript formatting for TypeScript files. That would help a lot. Let's see. There's a JavaScript file in here, right? Like, so if I look over here, right, like you can see, oh, that wasn't very interesting, but like you can see that it's index highlighted because Nano does index highlighting. So yeah, my workflow is basically, you know, Nano and then using our formatting tools or whatever. And then once something lands in GitHub, I can actually, you know, have a look at the diff. I can actually make sure that the continuous integration ran. And speaking of continuous integration, right, like this is the thing that is important both for my hobby projects as well as Honeycomb's projects. So you can see here that, you know, I have this cycle of always making sure to lint everything, to test it, to build it, and then to deploy it. And that we're able to control all these things from within Circle CI, which I think is really helpful to have as kind of one control center for thinking about, you know, what is the state of my code? Can I track where it is in the delivery pipeline?
Yes.
But yeah, I think that, you know, certainly there are more interesting pipelines. For instance, there are pipelines that are running by my colleagues at Honeycomb right now where you can see we have these massive pipelines that execute a bunch of parallel steps because it turns out that an application that is not just, you know, a JavaScript front end and back end, but instead a series of Go microservices that is built in a mono repo. So this is our main Honeycomb repo. That's a little bit more complex, right? So when we're looking at the continuous integration flow, one of the things that we like to think about is there another way of visualizing the speed with which things are getting to production? Spoiler alert, the answer is yes. So this is an example of being able to see what is it like to release a change at Honeycomb. Right, so we can see here that the overall build process takes about 15 minutes for all of this monorepo, all of the steps in the monorepo, and we can see what are all of the constituent components of it. So we can see, you know, how much time am I spending? How much time am I spending on the JavaScript tests, right? How much time am I spending on these 4 parallel Go tests that are being run because we partitioned the Go tests into 4 pieces, recognizing that if we ran them all in serial, it would take longer than the JavaScript tests, right? Like, so we're constantly trying to shrink what is the critical path, right? Like, what is causing this to take the longest? Because we want to make sure that it's always less than 15 minutes to production for us. So kind of, it's really, once you have Honeycomb, it's kind of or any distributed tracing tool, really, it's kind of like a hammer, right? Everything starts looking like a nail. So why is the build slow? That's actually a nail that you can hit with distributed tracing to figure out, okay, you know, why are all these build steps happening so slowly?
Yeah, that's super cool. I feel like a lot of people use distributed tracing tools right now, but probably a small percentage of them actually have that set up in CI. But it seems like, you know, now that you've like shown this, it seems like such an obvious application, because like how many times have you wondered like why is CI running so slowly and wanted to drill into that?
Yeah, and it's not that heavyweight actually, right? Like it is just a matter of adding one Circle CI orb. And then once you do that, then you can just add steps that say, you know, hey, I want to instrument this as a job, or hey, I want to instrument a bunch of fields into this so that I can track, you know, which branch am I on, or what was the size of the artifacts, which I think is a lot of fun.
There's a question from the. Oh, sorry. Go ahead.
I was just wondering if that was something public that you could share in case anyone wants to look at a good example.
Oh yeah, absolutely. So this is github.com honeycombio build events.
Cool. I love learning by example.
Yep,
Yeah.
so you can look at that. We also have a Circle CI orb. So if you look for the Circle CI orb, you can find our Circle CI orb in the partner repo for Circle CI.
Very cool. We'll also share that in the recap.
Yeah, awesome. That would be wonderful.
There's a question from the audience here asking, why do you like Circle CI for CI? Someone else uses GitHub Actions. Is there a reason that you prefer Circle?
It's the support for parallelism. It's that GitHub's support for kind of running many things in parallel and kind of having them all converge together is a little bit less mature. And that means that, a build that would take 10 minutes on Circle CI might take 20 or 30 minutes on a competing provider, or it might be harder to understand. There's also another factor which is important to mention, which is at the moment, GitHub Actions does not support ARM64, as far as I know. And one of the things that we've really embraced at Honeycomb has been the ARM64 processor architecture. So what's interesting about it is that it is more power efficient and therefore is cheap. The cloud provider can offer it at a cheaper cost and can offer better performance for the money. So because Circle CI has ARM64 support, we're able to utilize that in order to build Docker images natively and not have it take forever, and then to be able to run those Docker images directly in production. As it turns out, go ahead.
I mean, that is super interesting to me because, the main context I've heard about ARM64 is I think like Apple M1, that new processor.
Apple M1 or Raspberry Pis.
Yeah. And is Raspberry Pi on that?
Raspberry Pi is ARM64. That's why they're so cheap and so power efficient.
Wow. Okay, so I've heard rave reviews of the M1 laptop in terms of performance, and it almost seems too good to be true. I almost kind of assumed there was some Apple magic there, but
no, there is some, but it's all relating to the ARM64 architecture in general that all this is based on. And it turns out that Apple is not actually the only provider of ARM64 workstations that are affordable. For some definitions of affordable, Apple is actually pretty expensive. There is a markup, but
yeah.
I actually just SSH to another machine that is sitting right here under my desk as well. Not quite visible in that original photo that I showed. Let me see if I can find it. Right, this box right here. This box right here is an ARM64 box. This one is my AMD 64 box, and that's a printer.
Right.
So right now I'm connected to my ARM64 box, and you can see that it is, right now because I'm not heavily utilizing this at all times, and because it's not necessarily my primary desktop environment, right now I'm running, the Berkeley Open Internet computing infrastructure to fold proteins. But yeah, this is my ARM64 box. It's got 32 gigs of RAM, and it's got 16 cores. They're not very fast cores. They're 2.2 gigahertz cores, but it is really, really powerful. And guess what? That box, the CPU in that box is 25 watts. When you compare it to a comparable processor from AMD or Intel, that processor from AMD or Intel would suck 4 times as much power, be at least 100 watts of power dissipation. So I'm over here, right? Again, I've got all of my directories configured. I've got my Honeycomb workspaces, so I can build natively our binaries. But not all our developers have to do this because we have Circle CI. So therefore, we kind of have access to a central place to run all of our ARM64 builds.
Wow.
That's really cool. In your expert opinion, Liz, is there any reason, why shouldn't everyone just switch to ARM64? It seems like it's more energy efficient, it's more performant. Why stay on x86?
I think it's 2 reasons, right? If you are a game studio, your customers are going to be, for the foreseeable future, unless they're one of the Mac M1 early adopters, they're going to be running x86, probably Windows, right? So you kind of have to cater to that audience. But definitely for anything that you have the ability to build yourself and where you're running under controlled circumstances, yes, right? ARM64 is a very, very easy answer because it is 40% cheaper than the competition. But yeah, I think, there are issues where right now Amazon and Oracle are, and there are 3 choices in the ARM64 market in the cloud right now. It's Amazon, Oracle, and Equinix Metal Such Packet. Those are going to be your 3 choices for hosting. The problem of that is only Amazon is one of the major 3 cloud providers, right? You cannot go to Azure and get an ARM64 instance. You cannot go to Google and get an ARM64 instance. So, there are some trade-offs there. I happen to be fine with the lock-in, because we know in theory, if we needed to, we could go to back onto x86, another provider, right? We could pick Oracle for some reason, right? Like those are choices that we could make.
What's taking Azure and GCP so long?
I don't know. I think it's a strategic decision on their part, how closely aligned they are to Intel and AMD. The third provider was Packet or Equinix Metal.
Very cool.
Right. So let's see, where is it? Yep, metal.equinix.com. So they actually were some of the earliest pioneers of ARM64, except for they have a smaller market share than Amazon, so they weren't able to as aggressively promote as Amazon has been able to.
Yeah.
One of the other topics I know we wanted to get to was kind of, terminal setup, because I kind of live and die by my terminal, because I really because I don't use VS Code, right? Like I literally only use browser tabs and terminal. I have put a fair bit of effort into my terminal. So let's talk a little bit about my terminal. So one of the things you can see here is that it's, telling me which host am I on. And one of the other really cool things is if I go super deep, right? If I go into, right? If I go super deep, instead of the command line swallowing my entire window, right? I Powerline, which is this replacement for kind of the left-hand side of my command prompt, helps manage that complexity. So I see, okay, I'm working in the hound command poodle directory, right? None of these other things of how deeply nested I am really matter. Similarly, if I, right, if I do something, it'll tell me, hey, you've got a background job running, right? It'll warn me and say, hey, do you really need to close that tab without disowning the task?
Yeah.
So, right, lots of handy things to help me navigate, where am I among my, several machines, whether they be local machines, remote development machines, right? Like that helps me kind of keep tabs on where I am and what I'm doing.
That's pretty sweet. Did you do any customization of Powerline to get it displayed that way, or is that just more or less like the stock?
That's a good question. Nope. This is literally all it is.
Nice.
So it's just adding. It's an apt install plus 2 additions to your bash RC.
Yeah. Nice. Where would you say your kind of Unixy approach to dev environment comes from? Because there are these the two ends of the spectrum are this kind of approach where it's very minimal, very separated concerns, and then there's the camp of people who are everything in the IDE. For you, philosophically, or
it's partly philosophical and part pragmatic. Before COVID, I used to spend a lot of time on the road, so I was only developing with my Chromebook. My Chromebook is just not going to, run a heavyweight VS Code.
Yeah.
And also, I think, it dates back to the fact that I am by trade a systems engineer first and software engineer second, and therefore, kind of this, embracing Unix has been part of things from the get-go. I started using Linux on the desktop as my primary and only operating system from 2006. Yeah, I think from 2006 onwards, I have used nothing but Linux for any machine that I personally own.
Nice.
Have I tried GitHub code spaces for remote dev? No, I have not, but we do use the... we find it very handy for when we're pairing at Honeycomb to use VS Code online. You can share a VS Code window that is hosted on someone else's screen, and you can type in there as if you were typing on their own computer. It's really cool.
Is that the live share feature?
Yeah, it's the live share feature. we love the live share feature for pairing at Honeycomb. Is this year going to be the year of Linux on the desktop? Well, I have a few answers to that, which is, World of Warcraft runs fine. League used to run fine, although they're introducing proprietary DRM. EVE Online runs just fine on Linux. Steam runs just fine on Linux. So yeah, I'm going to say yes. especially given that like Proton is magical, right? Like Proton just unlocks this whole library. But this is not game time. This is DevTools time.
Wait, what is Proton? Just out of curiosity, is that like
so
a gaming...
Proton is a combination of technologies. It's a combination of Wine and DXVK. So Wine takes care of translating the kind of Windows syscalls into Linux syscalls, and DXVK translates direct 3D into Vulcan. So if I'll make sure I'm on the right machine. Yep, no yellow tab on the left. So what Vulcan is Vulcan is a tool that allows direct access to your physical graphics card, and Vulcan is therefore a lot more performant than even OpenGL or DirectX. So by having a direct translation layer between the graphics libraries that games developers use when developing for Windows and the underlying physical hardware, it means that the performance is nice and snappy, that you can get the same performance or even better performance than you would running on Windows with the same hardware from Linux. And that was kind of one of the major problems, right? Like, was lack of API compatibility, and when there was API compatibility, slowness and crashiness. And both of these problems are solved by Proton as a combination of kind of the syscall translation and the graphics library translation.
Cool. All right, well,
I guess this is kind of DevTools time in that, I used to be a game dev. I'm no longer a game dev, but I still like talking shop about game dev.
What did you? I'm curious. Like back when you were a game dev, did you have kind of the same sort of Unixy development environment, or was that like a very different world?
I did. So I worked at a studio that was called Three Rings Design, and we worked on a game called Puzzle Pirates. And one of the cool things about Puzzle Pirates is that the server and the client are written in Java, which means that it is just literally a Java plugin that like will work in your browser, or used to work until plugins got really severely deprecated. But like, right? Like,
this looks very old school. I'm assuming this was kind of back in the day, so to speak.
Yeah. This is like 2000. Game was founded 2001. It's still alive to this day, 20 years later. But yeah, I worked there from 2004 until 2007.
You're gonna see a surge in players now.
Yeah. Oh yeah. Of course. Right. Like, so you can see, right? Like, we made it so that it would run perfectly fine on Linux. Right. Like, here's the shell script that in turn calls Java.
Yeah.
Who knew? Right? Isn't that neat?
That's awesome.
So one of the cool things about it also is that at the time, the server was running on FreeBSD. We had one of the FreeBSD core developers on our team, and he really wanted to make sure that the stuff was as performant as it could be. And at the time, that meant FreeBSD. So we had Windows clients, Mac clients, Linux clients, and the backend was FreeBSD. And we were kind of most of the devs were either using Macs or using Linux.
Yeah. Wow. That's all right. First of all, I think that's like very idiosyncratic for the gaming industry, right? This is like very dominated. But also, I just want to call out that folks out there, you heard it here first. The future is going to be Linux on the desktop on top of ARM64, right?
You just may not recognize it, right? Like, hey, you might get a Chromebook one day, and hey, it happens to be ARM64 under the hood, and yes, it can run, Crustini, and it can run, Linux on it, and in fact, it's running Linux to provide the Chrome experience, anyways, right? Like, I think the future that we're seeing is kind of white boxed Linux, right? Where it's secretly Linux under the hood, no one tells you, right? Yeah. Same thing is true of the like Steam controller and the Steam box, right? The Steam box is a Linux machine. Mm-hmm. That's a game console. Mm-hmm. And it turns out that they're using Proton and all of these things to unlock the full Steam library.
Cool.
Yeah, in fact, we've even seen this at Honeycomb, where it used to be that every dev starting at Honeycomb got a Mac laptop, no exceptions.
Yeah.
And now, actually, we have, I think, about a third to a quarter of new engineers starting at the company pick Linux for their laptop or bring their own device and install Linux and connect to our network.
What hardware do they use for Linux? Like what laptop?
I'm not sure particularly.
Oh, is it just like up to that? There's no like standard?
Yeah, I don't think there's a standard. I don't know because like I haven't asked the company for hardware, but like I brought my own Chromebook, I brought my own desktop devices. Is the Chromebook finicky to install fonts? Yes. I had to go through a little bit of effort to make Powerline work from my Chromebook, but debugging complex things is my specialty. Whether it's, using tools like Honeycomb to bug things, or whether it's, debugging like, why is this package not installing, or why is my interface broken?
Thanks. Are we gonna have time for Terraform?
Yeah, I think so. So yes, writing the code, building the artifacts is one thing, but I think it's also important to talk about how do we actually deploy infrastructure to production. So in the case of my EVE Online hobby project, we're not big enough to really benefit from infrastructure as code. So it is pets all the way. But as far as Honeycomb is concerned, everything is cattle. So what we have is we manage our infrastructure using Chef and Terraform and a little bit of Kubernetes. We're starting to actually embrace Kubernetes. But one of the really cool things is embracing this idea of less than an hour to prod. We take this really seriously, not just for our code base, but also for if we make changes to Chef. What happens is the Chef repo gets packaged up as a tarball, and then that tarball gets scraped down by every host that we have, and the Chef recipes are executed once an hour. So that's kind of how we do continuous delivery of Chef. How we do continuous delivery of Terraform is with Terraform Cloud. So we have a variety of different environments, right? All of these environments have a bunch of Terraform rules that specify, what they do. And if anyone makes any change to them, what happens is you will get a, let's look to see, has someone made a Terraform change recently? Yes, a colleague has made a Terraform change recently. Let's have a look at this one. So we can see, what does that Terraform change actually look like? So we can see, that Terraform automatically, every time a commit lands in main, we automatically resync the state of our Amazon infrastructure with Terraform. And that means that we'll catch deviations really, really quickly, and that will automatically just smooth out any deviations and replace them with the known good state. And we find this to be really, really helpful. So this means that we have almost no config drift. It means that we're able to see what's about to go out. And in fact, for every environment except for production, it's just automatically applied without human intervention. So this way we can discourage people from making manual changes in the AWS console, right? Like, yes, of course I can make a change in the AWS console, right? But that's discouraged because that's not reproducible. So instead, what we have people do is they use Terraform, and that's kind of how we automatically apply things. If we do need to do something with the API, there actually is another thing that we use, which is, so, I'll go over here, I'll type in my password. Oops. A hidden window, right? But you can see here that, I'm spawning off a separate copy to re-authenticate every time that I access Amazon. That way I don't have Amazon credentials just sitting around on my machine, right? Same thing with your SSH keys. You don't want this stuff just sitting around on your machine.
Yeah. Would it be safe to say that no one should be interacting, everything ought to be going through Terraform for describing production state?
Yep, for making changes to production state. I think this is one of the super fun things, right? If you make the roads to production as easy as possible via automated processes, that means that you can mostly treat kind of your interaction with production as a, I'm going to inspect production through the lens of the telemetry rather than inspecting production by SSHing to it, right? We don't necessarily reach in and poke things either via SSH or via manual AWS console changes.
Yeah. How does that work? Because I think a lot of people coming from more of a SSH type background, the devil's advocate there would be like, well, there's always gonna be something. There's always gonna be some random error where you don't have the instrumentation that gives you enough insight, and so the best way is still just to get on the actual machine. Yeah,
there are a few cases, and we're working on reducing them. For instance, I'm excited about continuous profiling, which is going to eliminate the need to SSH in and run pprof. But at the moment, a majority of our instrumentation, right, is exported via OpenTelemetry or Honeycomb's SDKs, right, and we're able to visualize and understand all of the properties of our data, right? I can see here the number of events that I've ingested over the past 2 hours into Honeycomb. And I can ask questions like, hey, right? Show me what's going on with this data. Show me what's going on with this population of requests that are taking 10 to the 3.5 seconds or 10 to the 3.5 milliseconds. And Honeycomb will show me, right? Like, I think that this is a much more powerful mechanism almost than SSHing to individual machines, because I'm able to look at things across the entire fleet. And it's not just aggregated, it's looking at the overall picture of, what's going on with these events, why are they slow, and how can I make this situation faster for them? Or is this perfectly normal because they're sending us a lot of payload per packet, right?
Yeah, you are now the second person who I really respect and admire who's kind of mentioned shifting away from the SSH, more like sysadmin-y way of investigating production issues to this more kind of observability-oriented or like data-oriented way of doing things. The other person was Sugamaran, who's one of the founders of PlanetScale, and he said one of the like big moments, aha moments of him for him in his career was like making that switch when he joined Google, and they're like, no, you don't get to SSH into any of these machines. Everything, anything question you want to answer, you have to invest in some sort of chart or like thing, because that way when you answer it, the next person that comes along that runs into the same issue has a way to answer that question. They don't have to go through the same like process of like SSHing and the laborious and manual process of like figuring out what the heck is going on that specific machine.
And Liz, you mentioned that Honeycomb is like specifically built for team collaboration. Did you want to highlight any of those features as well?
Yeah, totally. So you'll notice that I'm kind of, as I was drilling through this, right, I started all the way back at, hey, I want to see all of the queries, right? I want to see all of the query volume. And I was able to hone in on this one user who is having an awful experience, right? Where they are seeing 10% of their queries be slow, right? And this is kind of one of those things where I could not just send a link to this in Slack to a colleague, but I can also, see every query that I've run. Every teammate of mine can see what I've run, so they can kind of follow along as I'm debugging it in real time at the same time as I am. And I think that's really cool. So, right, like, let's see, hey, what's going on with this, right? Like, let's look at one of these specific errors. I see what this is. This is someone who has a under-provisioned client of ours who therefore is taking forever to transmit the data. So it's not that we're slow, it's that their process is overwhelmed and is not transmitting data as fast as it can be. So yeah, definitely very different mentality. Another one that we haven't quite yet adopted, but we're close, is this idea of if you do have to SSH a machine, you could have done anything to that machine, so we may as well we may as well restart it with a clean copy after you're done SSHing it, right?
Right.
Not quite there yet, but I think that's kind of the aspiration that we have, is that everything should be kind of ephemeral, and if you do need to manually permute something, we'll stand up a clean copy of it afterwards, so that there's no possibility that you are relying on a hack that someone did a long time ago and hoping that it doesn't restart. We'd rather find that out sooner.
To be respectful of Liz's time, Liz, are you able to go through some of these additional questions?
Yeah, absolutely. Let's start with the one about Terraform providers. So one of the cool things that we do with Terraform is we use the Terraform provider for managing your G Suite accounts and for managing your Google account metadata. So what that means is we are able to store information about which users are authorized to access which parts of AWS. And that actually gets encoded into the way that we access AWS. So the thing I was mentioning earlier where I said, oh yes, I can just, I can pull open AWS, and it uses my Google authentication and it lets me get in, right? That is not, me having a static account configured. That is actually it checking with G Suite, am I authorized to access the platform set of permissions, right? And that's configured via a Terraform provider. So we have a list of all of our employees, and we have basically this file that says, okay, right, like, these employees are currently authorized to access AWS, and these employees are authorized to view AWS, and these employees need their permissions de-authenticated, right? So I think that that's one of the most interesting Terraform providers that we use, is kind of that centralized control of how people get into AWS in the first place and our employee directory. Let's see, ARM China. I'm not actually familiar with that. The thing that I am aware of actually is Longsun. So Longsun is a Chinese manufacturer that is working on a MIPS-like architecture that is going to compete with ARM and x86. In particular, they're touting that, because it's developed and designed in China, that it complies with China's national security requirements in a way that x86 and ARM doesn't. I don't think that ARM, ARM is an open standard. There are many implementers of it and licensors of it. So I think that there is a huge adoption of ARM-based systems. If anything, it's actually the NVIDIA acquisition of ARM that has people running a little scared that NVIDIA is going to squeeze its competitors that are trying to use ARM. But, open licensing, hopefully they actually adhere to that promise so that we get many more wonderful ARM systems like Graviton 2 and like the Honeycomb ITX board. No relation to Honeycomb, the company that I work for, but the Honeycomb ITX board I was showing earlier. Someone asked, do they have Screen Hero and VS Code? Yeah, it's basically, let's see. No, I guess none of my coworkers currently have a VS Code workspace open and shared with me that I could show you. But yeah, it's really slick. It's literally just here.
Even better than Screen Hero, right? Because you can have independent cursors.
Yep. So you just open up the live share, pack, and it basically will allow someone to collaborate. It'll show you where their cursor is, and it'll let you work in any tab that you have open as well. It's actually how my colleague Max and I developed some of the demo that we did of the Honeycomb metrics feature at Honeycon this year. Was we were pairing in VS Code and kind of, both like being like, why doesn't this compile? Okay, what if I change this? What if you change that? And then it all came together. It was magical. Someone asked the Ide Dev Workflow. Yeah, so the Ide Dev Workflow is literally so. I'll pull my code. I hope I'm on a good branch. Yep, I'm on a good branch. Branches of these are alive. Okay. Right. So I've recently added a feature flag. Like 2 months ago, I added a feature flag to turn on reading from Kafka based off of the availability zone. So if I do that, you can see the kind of code changes that I might make. And then if I go to one of the affected binaries and I run go build, I'll get a binary out. In fact, I probably should have run go install, but that's fine. So that's how I might locally test something. And then once it is ready to go to production, in fact, because this is less than 2 months ago, I can show you, right, like is, it's here, there's the binary, right, it's built. Oh, that's not gonna work, but, you can see here that it's a elf executable built with Go. Whoa, that's cool. I didn't realize that Go attached that metadata right there, and it was readable by file. That's cool. Right, so you can see which pull request was this. That's going to be in here. So you can see here, we can go ahead and find this, and we can see that it was successfully built. That was successfully built within 17 minutes once I got code review and got it approved. And then it went out to production probably within about 10 or 15 minutes, and I can go to launch darkly. Oh, I guess which I didn't show. And basically, because we decouple releases from deploys, that means that I can. I really wish all these things took security keys, so I wouldn't have to reach for my two-factor codes, right? Like, right. So there's this feature flag. So it can be tuned on a per environment basis. So if I go to dog food, I can see that I turned it on. see. Yep, there it is, right? Liz created the flag, Liz turned on the flag. So that's kind of what a release process looks like, is write the diff, test it locally, push it, get a code review, get it merged, and then turn on the feature flag and watch as it actually goes out. The watching as it goes out is really, really important, right? So as you can see here, we made the change in the dog food environment. So I would need to go to the kibble environment in order to see what the result of that was. So, it's turtles all the way down. There's, 2 layers of Honeycomb underlying all of this that we use to make sure that each layer is behaving correctly. So for instance, I can look here and I can make sure that, when was this turned on? This was turned on July 6th. I am not too late. So if I go to Shepherd, I can go and look on July 6th. July 5th to July 7th. And I can make sure that when I turn this on, that I didn't adversely impact anything. What time did I turn it on? At 10:56 a.m. 10:56. Okay, right, so I can clearly see here, no, I didn't cause that. That was already happening. And I can see that the feature flag being turned on didn't affect it, right? And conversely, I can go and look at retriever timings, right? And and again, I can check, hey, what happened here?
Yeah.
Right, and I can make sure that how badly did it fall behind when I made the change?
Yeah.
And actually, that's interesting, right? You can actually see a noticeable change that happened there, right? And I might dig into that. So that's kind of how we think about it, is you have to close the loop. You have to actually watch it running in production, or you are not actually doing a good job of kind of full stack ownership.
Yeah.
This is
Someone asked,
awesome.
did they see a tilt file?
Yes, there is a tilt file. So our developers, mostly our Mac developers, actually are huge fans of tilt because it kind of automates this process of getting all of our Docker containers running, of automatically refreshing if we change code live. So yeah, it basically is a mechanism for us to launch all of our microservices because we are a massively horizontally scaled shop. We have about half a dozen microservices, and running one copy of each is actually relatively inexpensive, right? We just kind of stretch them to fit the size of a machine and scale them out horizontally in prod. But if you're running something locally, you need 6 services running. So we have in Tilt the ability to stand all these things up. So I personally, because I tend to work on only one service at a time, I tend to not use Tilt myself, but a lot of our devs are a huge fan of it. So for people who aren't familiar, it is tilt.dev.
It's like the developer environment tool for like a multi-service or microservice world. Would you say that's accurate?
Yep, exactly so. Someone did have the question of, given that we're a mono repo, do we selectively build, test, and deploy, or do we build everything? The answer is we build everything. Not necessarily, not necessarily when we're testing locally, right? We'll do a spot check of the functionality, but we want to make sure we don't introduce any regressions. And when we deploy, we're deploying all of our services at the same build stamp. Even if nothing changed, because we want to make sure that we are able to push all of our services at any time. And it turns out, if you look at the history, so if I go to UI dog food again, and I go to, let's go to a cheaper data set to query, you can see over the past 60 days. Oops. Oh, good. We stopped doing the bad behavior. So if I plot count distinct build ID, you can see that I need to turn off the deploy markers, right? So you can see that we run, something like, granularity is 1 day. There we go, that's better. Yeah, so you can see that we run up to 12 different builds per day, right? We're deploying once an hour. So they're, it's a mechanism of keeping everything fresh, every service.
I think we're through with all the questions, right?
Yeah, I think we got through everything.
Yeah.
Yay.
Thank you so much. This was super enlightening.
Yep.
Yeah, we're definitely kind of at the forefront of what you can do, but that's not a reason to be intimidated from taking kind of any of the first steps, right? I think that first step is knowing what is your build time like, and then instrumenting it, and then figuring out how can I make it faster, right? If you go from 1 week builds to daily builds, that's at least a small step. Tap only tested the steps that are affected. Was it good or bad? Yes, technically tap only tests. They're talking about a Google specific thing. So tap is kind of the global build queue at Google, and because of Google's size and scale, no, you're not going to run every test on every commit. You have to only run the tests that changed. At our size and scale, as I was mentioning, right, like as I was showing earlier, in fact, let me use my query history to do this because it's going to be faster than recreating the query, right? This is the joy of the shared brain. User Liz at honeycomb.io. Build -events. Right, if I'm looking at a given build trace, and I see that all of the right, if I see that something is especially slow, right, of course I'm going to fix it. But like, if I'm able to keep the build time under 15 minutes just by adding more parallelism, I'm happy to spend the Circle CI credits to do that, right? Like, we're not yet at the stage of wanting to run partial builds. There is a startup that is specializing in this problem of only rebuilding what you need to. But in our case, we would rather spend, an extra several $100s per month even on Circle CI credits for rerunning tests that haven't changed than risking breaking things because we failed to run the right test. The other thing is that tap does spot check. Tap does spot check like every 10 or 15 or 20 pull requests. It'll actually build the whole world and test the whole world.
Is that your base, the startup that you're referring to, or some other company that does the...
No, it's some other company that does partial builds and identifies via, I think, dependency checking or machine learning or something, like which builds to run. But yeah, I don't remember the name of it offhand, but they demoed it to me, and I was like, "This is cool, but this is not for us yet," because we're able to shard and move faster with parallel instead of instead of trying to cut the number of tests that we run.
Yep.
Will deploying all services become an issue as our services scale? Yes, but our lesson is we don't prematurely optimize in general. So we wrote a blog recently that was about this exact problem, which is, yeah, sure, but that won't scale, right? It turns out that you do the thing that won't scale anyways until it stops scaling, right? And you wind up hitting that limit surprisingly later than you thought it would, right? Basically, we had this product feature running in production for, I think, a year and a half, and we had kept on putting off optimizing it, right? And eventually we did decide to optimize it, but a year and a half later than we thought we'd need to, right? And when we did, suddenly the amount of data that we needed to compute suddenly went down, and then we had a lot more headroom, right? I think about that the same way as we think about kind of other technical solutions. The problem that we're addressing and feeling right now is not actually relating to deploying all services. Instead, the problem relates to just kind of management of individual deploys, right? Like, we're not even in a position to think about deploying individual services until we can make deploying all of our services work smoothly so that we know what's running at any given point in time. So that's actually part of why we're investigating using Kubernetes now to manage our service state. What's the magic wand question?
If you had a magic wand, what would you change?
If I had a magic wand, the thing that I would change is I would change the kind of, I guess, futile attitude that people have of, oh, this is just broken and we're just going to live with it forever and it's going to be broken forever, right? I think that is the number one thing that I encounter every now and then, and I want to basically be like, put yourselves together, like, you can improve, like, you are not hopeless, all hope is not lost, like, you are not doomed to be on call and paged every single night at 2 a.m. That is not a status quo you have to accept. So that is the thing that I would fix it with a magic wand, is kind of get rid of that sense of futility, and give people back a sense of curiosity and wonder about what they're doing.
Preach. And given a magic wand to create any tool that you would need?
You know, I frankly am I feel like I got that magic wand when I started working at Honeycomb.
Nice.
It kind of was really cool seeing that the stuff that I did at Google had had something that was even better than it on the outside. That was really cool to see. But I think most of the wishes that I wish for with a magic wand are more things that relate to smashing capitalism and smashing the patriarchy and smashing racism. I think that's what I'd use my magic wand wishes on.
That's awesome.
I do use Nano for coding, to answer the person who asked. So in fact, right, like I was using less in this particular case as I was showing people the tilt file, but I do very much use Nano for my day-to-day coding.
Well, this has been amazing. I think we have answered all the questions, and feel free to reach out afterwards if you have any more. Tweet to us, tweet to Liz. This is Liz's Twitter. So you can definitely follow her, and also tweet with the hashtag of DevToolTime, and I'm sure we'll be able to answer any of your questions. And thank you again so much, Liz, for being here. You've, I think, enlightened us in so many different ways, and I'm so happy we've got to cover all the tools plus more. So It's been a pleasure. Yay.
Thank you so much.
And I hope that y'all join us for the next DevToolTime, September 15th. We'll be talking to Paul Jolly. So join us there as well. And yeah, looking forward to see y'all again. Bye, everyone.